Welcome students, welcome to the session. Today we are going to discuss system of particles and rotational motion. Now student, why do we say system of particles? It is because if I consider say this mass, this particular mass can be assumed to be made up of many small particles. This mass is made up of many small particles. All the particles are distributed over the given length. That is why we say this can be called as a system of particles. Rotational motion. You are clear with horizontal motion, translatory motion, vertical motion, projectile motion. Now this is rotational motion. In rotational motion, there will be one axis about which all the particles will rotate. Now let us understand step by step this thing. As we were talking of system of particles, this means the particles are throughout distributed over a given length. Now if I apply a force on it, how will the body behave towards that force? The body will behave as if that force is applied at a point where the whole mass, which is actually distributed, appears to be concentrated at a point. Appears to be, so this is apparent to be concentrated at a point. That point is known as center of mass. So the first that we come across is known as center of mass. What is center of mass? You have come across the word center of gravity, correct? Center of mass, this one is center of mass. Center of gravity is the point where weight or the force because of earth on the body acts. The point where the weight of the body acts is center of gravity. Now center of mass is what? See, center of gravity is actual point. It's a real point. Center of mass is a virtual point. Center of mass is a point where the entire mass of the body can be assumed to be concentrated. Now when we talk of this, then how do we find that center of mass? Say for example, there is one mass here M1, there is another mass here M2. Now if I take a Cartesian plane for this, we have M1 will have some coordinate, M2 will have some coordinate, say x2, y2, M1 has coordinate M1, y1. Now, what we can say is, the x coordinate of the center of mass is given by M1, x1 plus M2, x2 plus M3 upon M1 plus M2. This is what we say as the x coordinate of the center of mass. Similarly, the y coordinate of center of mass M1 y1 plus M2 y2 upon M1 plus M2. This is what we have for two particles. Now say for example M1 is equal to M2. So you will get this as x1 plus x2 by 2, y1 plus y2 by 2. Now what if there are n particles? So for n particles, we will say x coordinate will be M1 x1 plus M2 x2 plus M3 x3. Like this it will go upon M1 plus M2 plus M3. This is exactly how we can write. This you can write as sigma of Mi xi by sigma of m. This is also you can write this way, and you can say this is the x coordinate of the center of mass. Similarly, Y coordinate of the center of mass can be written as m1y1 plus m2y2 plus m3y3. Like this it will go upon m1 plus m2 plus m3 this way. So again this can be written as sigma of mi upon sigma of m. This is how we can write the x coordinate and the y coordinate. You can extend it to z coordinate also if it is given a three-dimensional one for a center of mass. Now this is when we have particles separate discrete ones. This can also be written in vector form. If we try to write this in vector form, how will it be? This is the Cartesian form. So in vector form, please see this we can call as R1 vector. This we can call as R2 vector, right? So in vector form, the x coordinate of the center of mass can be said as m1 r1 plus m2 r2 upon, you can say, m1 plus m2. This is what you can call it as r vector of center of mass. This is what we can say. Now for n particles, we can say r vector, position vector of center of mass, is m1 r1 plus m2 r2 plus m3 r3. See, this is how r1 vector is the position vector of m1, r2 vector is the position vector of m2, like that all the position vectors upon, you can say, m1 plus m2 plus m3, like this for the all the particles. That is why we have system of particles. That is how we can get the position vector of the center of mass for discrete particles which are distributed. Now the question arises, what if the particles are continuous? For, like, say this kind of, here we have a uniform distribution of mass. In case of uniform distribution of mass, what we can do is, this can be divided into small mass. See, for continuous mass distribution, what we can say is x can be said as, because sigma of mi ri, right, that can be converted to integration, and what will be that? Integration of m into dx upon integration of dm. This is exactly how we are going to find the x coordinate. Similarly, if you want y coordinate, m into dy by sigma of dm, because sigma is what? Summation. Integration of dm will give you total mass. That is exactly how for continuous mass distribution, this is how we can write y. You can write y is equal to sigma of m into dy upon integration of dm. Sigma is summation, integration is also summation. The difference is sigma notation is to be used for discrete, when particles are distributed, then we use sigma notation. But when we have a continuous mass distribution, we go for integration. We replace the sigma by integration, and both are summation. Students, you see this, here I have taken m and dx. Now suppose mass is changing, so you can write this as x dm. and this you can write as dm. This way you can write. So here also, if y, so you can write y dm. This is how you can replace it, and you can write here dm. That is exactly how, because mass, your mass is changing. Like say for example, it will be given to you, mass is changing over the length by a given relation. So dm we have here. Otherwise, suppose mass is changing with distance, then it is taken this way. So it is to be converted into the form which is given in the numerical. Accordingly, we have to transform it. Well students, let us take one numerical to highlight how to use the expression for the center of mass. Two expressions we have seen. One is for a discrete mass, where the masses are of each particle is separately given, like in terms of m1, m2, m3, m4, like that. Their coordinates are given as x1, x2, x3, y1, y2, y3. Second expression is for continuous mass distribution, where we saw x coordinate of the center of mass is integration of x into dm upon integration of dm, or m into dx upon this. Now in this case, three bodies of equal masses, which means m1 is equal to m2 is equal to m3 is equal to m, are placed at, so 0 0, a comma 0, a by 2 comma a root 3 by 2. These are the three coordinates. Now x coordinate of center of mass will be m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. This is what we have. So now substitute m, x1 is 0 plus m, x2 is a plus m, x3 is a by 2. This is what we have, divided by m1 plus m2 plus m3. So this gives us, this is 0, m a plus ma by 2. So we get 3ma by 2 by 3m. So x coordinate we get 3m cancels, so we get a by 2. This is the x coordinate of center of mass. Similarly, now let us try to find the y coordinate of the center of mass. So the y coordinate of center of mass will be m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. So m1 is m, y1 is 0, m2 is m, y2 is also 0. Say 0, 0, root 3a by 2. So plus m, this is root 3a by 2 upon 3m. This is what we get. So what we get, this y coordinate of center of mass, this we get as, this is 0, this is 0. M cancels out. So root 3 by 6a. This is what is the coordinate. Hence, what will be the coordinate of the center of mass? A by 2 root 3 a by 6. That is exactly how we can use this formula for discrete particles. Students, discrete particle means particles which are independently placed at different points, like m1 placed at x1 y1, m2 placed at x2 y2, m3 placed at x3 y3. This is called discrete. In that case, you can use this formula. Well students, let us take one more question of the same type, but this is little different. Three bodies of equal masses are placed at the corners of an equilateral triangle. So equilateral triangle means a side is known to us. Let us say the side is A. So what we can say? Side of equilateral triangle This is A. This is what we can say. Find the coordinates of the center of mass. Now, please see this. This is an equilateral triangle. A, B, C. Here I have a mass M, here I have a mass M, and here I have a mass M. The side is given as A. So now, there are three different particles. So how will we find the center of mass? We must know the x and y coordinate of each of the masses. For that, what is to be done is, assume that the coordinate axis passes through one of the vertex. Let us say our coordinate axis is this. This is x and this is y. So what will be the coordinate of B? 0, 0. What will be the coordinate of C? It will be A, 0. What will be the coordinate of A? Yes, this is very interesting. How to find the coordinate of A? Coordinate of A will be, see, this angle is 60 degree because it is an equilateral triangle. So this side will be A cos 60, hence A by 2. And this side will be A sin 60, it is root 3 by 2A. So by using simple trigonometry, we can find the coordinates of the point. Now we have all the 3 points. This is exactly what the twist was in this question, because coordinates are not given. If the coordinates are given, then it's simple, m1 x1, m2 x2, m3 x3, that way we can do. But you have to generate this. Now students, please keep this in mind. Another student will say, no, I will take this as origin. Correct. Some other student will say, I will take C as origin. No problem. You can take any point as the origin. It doesn't matter. With respect to that point as origin, you will get the coordinate of the center of mass. Position of the center of mass will not change, but the coordinates of the center of mass will definitely change based on the reference, that is which vertex you have taken as origin. If you plot that point, it will remain same, but the coordinates change because reference origin is changing. That is why. So don't compare your answer with other students, because the other student might have taken some other vertex as the origin, so it won't match. Now how to find in this case? So if I say x coordinate of center of mass, so we have m1 x1 plus m2 x2 plus m3 x3 upon m1 plus m2 plus m3, because there are 3 masses. Substitute now. m1 x1, if we take a, so m into a by 2 plus m into 0 plus m into a divided by m1 plus m2 plus m3. So what we get? This is 0. M into a plus m into a by 2. So this will give us 3m a by 2 upon 3m. So from this we can say x coordinate of center of mass is 3m cancels out. So we get a by 2. We got the x coordinate. Similarly, what about the y coordinate of center of mass? It is m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. Now substitute the values. So what we get? M. y1 is root 3a by 2 plus m. This is 0, and third one is also 0. M into 0 upon, we say, 3m. So what we get the y coordinate as? Y coordinate will come out, m cancels out, root 3 a by 6. So that is exactly how we have to go for center of mass. So this is how for discrete particle we are going to use this equation to find the coordinates of the center of mass. Well students, let us take one numerical which will highlight the use of continuous mass distribution that we had discussed. See, the question is like this: if linear density of a rod of length 3 meter varies as lambda is 2 plus x, find the position of the center of mass. Now, in order to find the position of center of mass, what is given? It says linear density. What is the meaning of linear density? Mass per unit length. So, it is we can write this way, given dm by dx. This is your lambda, this is your 2 plus x. So from this we can say dm is equal to 2 plus x dx. Now, x coordinate of the center of mass can be said as integration of dm in x into dm upon integration of dm. This is what we can say, because mass is varying with distance. That is why we will use this equation, not m into dx. This is what we get, x into dm. Now substitute the values. X, dm is what? Dm is 2 plus x dx. Now please keep in mind, you cannot cancel that. Dm is 2 plus x into dx. What will be the limits of integration? It says length of the rod is 3 meter. So here limits will be from 0 to 3. From 0 to 3. So this gives us what? Go on integrating this. So if we integrate this, we get x is equal to integration of 2x plus x square dx. This is what we get from 0 to 3 in the numerator. Denominator, it is 2 plus x and dx from 0 to 3. So when you integrate this, what you will get? 2x is x square by 2, 2 cancels out, you will get x square will give you x cube by 3, and this is from 0 to 3. Here we will have 2x, x is x square by 2 from 0 to 3. This is how we have to find the x coordinate or the coordinates of center of mass when mass is distributed over length. So if we substitute the limits, this will be 9 and this will be 27 by 3. This is again 9 upon 6 plus this is 3 square is 9 by 2. So this is 18 and this is exactly what we get. Simplify this. That is 12 by 7 meter from the origin, from the one end which you have considered as origin. So we get the location of center of mass. This is exactly what is to be done whenever there is a distribution of mass with distance. Students, let us take one question to understand how to use the vector form to find the center of mass of a system of particles. Two bodies of mass 1 kg. So given M1 is 1 kg and M2 is 3 kg. Have position vectors. R1 is I plus 2j plus k. This is given as R1, and R2 vector is given as minus of 3i minus of 2j plus k. This is what we have. Now we have to find out position of center of mass. Now position vector of center of mass is given as m1 r1 plus m2 r2 upon m1 plus m2. This is what we have. So m1 is 1, r1 is I plus 2j plus k plus m2 is 3 times minus 3i minus 2j plus k upon 1 plus 3. So simplify this. If we simplify this, what we get? R, which is of center of mass, is I minus 9i. So we can say I plus 2j plus k, and this is 3, so minus 9i minus 6j plus 3k upon 4. This is what we have. Now simplify this. 9i, so this is minus of 8i, 6i, so this is minus of 4j plus 4k. So this can be, you can write it in this form, or we can say position vector of center of mass minus 2i minus j plus k. This is exactly how we can say the position of center of mass. If it is given in the vector form, we can use it. Students, now let us take one more question. Here, see, the data is not given in any of the form that we are familiar with. So how to solve such type of questions? Please try to record the data which is given in the question. 3 identical spheres, each of mass 1 kg, are placed touching each other with their centers on a straight line. Centers are on a straight line, their centers are marked. So diagrammatically, if I see, it will be like this. Let us say we have P here. This is one. This is what we have, 3 spheres. Now P, Q, R. Now, how to find the center of mass? Consider that this is our y-axis and this is our x-axis. Now, the coordinates, see this one. Now what we can say now? Position of the center of mass is m1 x1, m2 x2, m3 x3 upon m1 plus m2 plus m3. So what we have? m1 is 1 kg, this is 0. This is 1 kg. What is the x coordinate of q? pq. Plus m3 is 1. What is the x coordinate of r? pr. Divided by 1 plus 1 plus 1. So what we get? This is pq plus pr divided by 3. See, if the radius is known to us of the sphere, we could have found out that way. But since you see this, what is given in terms of pqr only, we have to find out. That is exactly how we can locate the center of mass. See, just coordinate, we have to identify what will be the coordinate of the centers, and it becomes easy. We have used the same formula, there was no difference, but the way data is given is little different. That is why please try to understand this question and try to solve once again by yourself. Students, let us take one more question. It is given in the diagram form. It says, find the coordinate of center of mass of a system as shown in the figure. Let us say there are three different figures. You can take it as one is solid sphere, one is hollow sphere, one is disc, or a ring, spheres, like that. Anyway, their masses are m each, and the coordinates of the centers are given. So, how to find the position of the center of mass? So, here x coordinate of center of mass will be, there are three masses, so we will take m1 x1 plus m2 x2 plus m3 x3 divided by m1 plus m2 plus m3. Now let us identify the x coordinates. For m, first one I am taking this is 0. For the second one it is a, and for the third one also it is 0 upon m plus m plus m. This is what we have. So this comes out as 0, this is 0, m into a by 3m, so it is a by 3. This is the x coordinate of center of mass. Now let us try to find the y coordinate. Y coordinate of center of mass, it is m1 y1 plus m2 y2 plus m3 y3 upon m1 plus m2 plus m3. This is what we have. Now pick the y coordinates and substitute. So what we get? m1 m and 0, m2 is m, it is also 0, and m3 is m and it is a upon m plus m plus m. So we get this also as a by 3 as the y coordinate of center of mass. So the coordinate of the center of mass is a by 3, a by 3. So students, this is exactly how, depending on the data which is given, we are supposed to use those two formulae only are there in center of mass. So you have to understand how to use these two in which situation.